Hi, welcome to GRE Free Prep Hour. Good to have you guys all here. More people are coming in. Um, my name is Kat. I am a GRE instructor for Manhattan Prep, obviously. In addition to teaching the GRE, I also am an instructor manager working with training and professional development for other teachers, and I do some work with GRE curriculum as well. So very excited to be here with all of you tonight. One tool we're going to be using a lot tonight is the chat function. We're going to be doing a lot of communicating through that. So I'd like you all to take a moment, go ahead and find the chat, and then you'll see it has a field that says to. Select all panelists and attendees. So set that to field to all panelists and attendees. And then chat us, where are you signing in from tonight? So go ahead, find the chat. Detroit, yay. Florida, oh, a couple of people from Florida, nice. North Carolina, DC, warm places. Ah, Marion, I'm from Massachusetts originally. Yeah, Elsie's from Boston. Cool, I grew up in Newton, just outside of Boston. Ah, Hawaii. Ah, super jealous, Kia. Hawaii is like the most beautiful place. Um, if you, we made this product called GRE Interact, which is like an online self-study program you might want to check out. We do a free trial of it. I worked a lot on that, and it has, thanks to me, a kind of low-key Hawaii theme, because when we were making it, I thought I was going to move to Honolulu. But I didn't. I'm in Brooklyn, New York. Brittany, are you in New York City? Or are you in another part of New York? Oh, nice. Austin. My mom's family's all in Austin. Very cool. Well, welcome. Good to have you here from all over the place. Looking forward to doing some GRE stuff with you. So tonight, all of the problems that we're going to do, or most of them, there are a couple that I kind of made up, but most of them are from this book, the 5-pound book of GRE problems. If you are going to get 2 GRE books, I would say make this one of them. The other one to get is the official guide. It's made by the people who make the test. But then this is great. It's divided up by topic in each chapter, and each chapter goes from pretty easy problems to pretty hard problems. So it has the full scope of everything you need to practice. And as you see tonight, I think we're going to start with some easier problems. We're going to work our way up to some stuff that I think is pretty tricky and might feel pretty challenging, but hopefully in a useful and fun way. So tonight's class is going to be about exponents because they are a quant topic that a lot of people really don't like. Does that resonate with anyone? Is anyone like, oh, when I see exponents on the test, I immediately kind of die a little inside? Yeah, Megan. Yep, Janelle. Cool. All right. Maybe I can hopefully get you to feel a little better about that. If you really like exponents, if you like quant, hopefully we'll also see some problems that are kind of fun and cool. And so for people who think quant is fun and cool, we'll get some of that. And for people who think quant is scary and unpleasant, hopefully I can help you feel better about that as well. We're going to start with like real basics, exponents, exponent rules, do a little quiz, and then we're going to look at a few different tricks that come up in exponent problems, particularly looking at the comparison, the quantitative comparison questions, and then getting into some other stuff. One more question for you all before we dive in. Is anyone totally new to GRE? Like this is your sort of first exposure, you're just starting to study? Oh, yay, nice. Cool. All right, yeah, we have a bunch of people who are new. Awesome. So along the way, I'm going to try and talk a little bit about just some of the basics of some of the problem formats we're looking at so you can start getting comfortable. So for the many of you who are new, I'll fill you in on everything you need to know to solve these questions. And if you've been studying for a while, it might be a nice refresher. All right, so let's talk about exponents. Something that to me makes exponents seem way less scary is just remembering what they actually are. When I write exponents like this with the superscript, like 5 to the 4th or 7 to the 6th, I think it can look really complicated or just look weird, and that throws us off. But exponents are just shorthand for multiplication. That's it. So, you know, for example, if I gave you 3 plus 3 plus 3, you could say, oh yeah, I could write that also as 3 times 3. Like multiplication is as a shorthand for repeated addition. An exponent is just a shorthand for repeated multiplication. That's all it is. So if you get a problem with exponents and the exponents are the thing that is bothering you in that problem, it's not a bad idea to just write out what it really is. Like, oh, it's just 5 multiplied together 4 times, or z 6 times, or some number of 2's multiplied together. That's it. My colleague has a rhyme for it. When in doubt, expand it out. So just remind yourself of what you're working with. Now, I think this is where we get into stuff people don't love about exponents, which is exponent rules. I'm going to walk you through the sort of basic exponent operations that you might have to do on the test. You might want to take a moment and write these down as we go through them, because we're going to do a bunch of problems that use those rules. So you might want to make like a little, either screenshot these slides or note it in your notebook, make a little cheat sheet for yourself before we get into doing problems. When I multiply 2 exponents with the same base, so like a to the 5th and a to the 3rd, then I add those exponents together. So I then end up with a multiplied together 8 times. The super, super, super important thing here is it is the same base. So I can't use this rule if I have different bases. I can only use it if I have the same number on the base. Division is the opposite of multiplication. So when I divide things with the same base, then I subtract the exponents. So instead of adding, I subtract. But once again, really, really important thing, same base. If they don't have the same base, you can't apply these rules. So watch out. We're going to do at least one problem where I think people are going to be tempted to combine exponents with different bases. Don't do that. Anything to the 0 is 1. So 2 to the 0, 1,000 to the 0, always 1. And then I think negative exponents maybe are one of the ones that tend to throw people off more, because it's an exponent and a negative. It's two things that a lot of us don't like combined. All you do when you see a negative exponent is flip it. So if you have something like this, it becomes a fraction. If I had something like this, 1 over a to the negative 2nd, already a fraction, what would that be? You can tell us in the chat if you see it. You can use the little like caret, you know, in place of an exponent sign. Yeah, nice. It's going to be a squared. Cool. So I just flip it around. And that's all negative exponents are. Nothing scarier than that. Questions on anything here? Cool. Also, feel free to, throw questions in the chat at any point if I go too fast over something or you want clarification on something. Like, please don't hesitate to interrupt with questions. You should always ask questions. Okay. When I take an exponent and I raise it to another exponent like this, then I multiply those exponents together. Finally, if I have two things inside parentheses, I can distribute that exponent to both of those things. Now, something to watch out for here. If I have something like this, it is not the same as something like this. Here, the fourth only applies to the b. Here, it applies to both of them. So in a lot of quant, parentheses are very much your friend. Be very diligent about writing them in. You may find places where you even want to add them in to keep things very clear, often with exponents or with positives or negatives. All right. So we're going to do a quiz. We've gone over the rules. I'm going to give you maybe a minute or 2 minutes, just to try as many of the problems in this quiz as you can. Let's see how it goes. Try out applying these rules. Here you go. All right, let's pause there. Don't worry if you didn't finish all of them. I know some of you, this is probably the first time you're seeing this stuff, so it's cool. Here are the answers. I realized the numbering on these didn't show up, so I'm gonna number them quickly now. And what I would love is if there are any of these that you don't really feel clear on, you're like, I don't know why it works that way or how it got that way, you want to talk more about it, just chat in the numbers of the ones here that aren't super clear to you. Don't know why my numbers did not show up on the slide. Ooh, yeah, 5 is popular. 5 is weird. Yep. Yeah. So Lauren and Janelle, something that you may find, actually everyone I think may find this helpful at some point. If you get a problem and like you guys felt good about number 4, right? So if you get a problem like 5 where suddenly there's variables involved and the variables freak you out, just imagine it with numbers. Like if I told you this, x squared to the negative third, what would that be? Yeah, yep, it would be x to the negative 6th. So it's just the same thing here, only instead of 2 and negative 3, I multiply y and negative z together to get x to the negative yz. And then if I wanted to, I could also write this like this, sort of either this form, or both good. That make more sense now? Cool. Very similar thing for number 6. First of all, y by itself, I could also write as y to the first. Like 3 is also 3 to the first. So if I gave you y to the first times y to the second, that would be really similar to number 9. You know, where I'm just adding up all the exponents. So I do, y to the 1 plus 2 is y to the third. But here I have n. So I just imagine this same operation with n instead, and I get 1 plus n in the exponent. So confused by exponents, then, by variables, just imagine it with numbers. Yeah, totally cool to write 8 as 1 over x. And Amber, probably you would have other information in the problem that would tell you if you wanted this format or this format. Usually in quant, it's a good idea to glance at your answer choices because then you'll see, oh, I'm looking for the fraction format, or oh, I'm looking for the negative format. So being able to go back and forth between these two is good. Cool. And did anyone have a question I didn't cover? I see. Ooh, Megan, that's a cool question. So Megan asked in number 4, why does only the exponent get multiplied and not the integer? Yeah. So, and why is it different from number 1? So in number 1, it's like both 7 and z are bases. So I apply this to both bases. But here I only have one base. I only have the 2. So I'm going to multiply the exponents together. Like 2, I could imagine this also as 4 to the 5th, right? Because 2 squared is 4. And then I just say, oh yeah, I just apply the 5 to the 4. So I want to apply the exponent to each base, but I'm not going to apply it to both the base and the exponent. Like 2 squared is sort of one thing. Megan, does that make more sense? Awesome. Cool. I'm going to go ahead and clear those. All right, so now we're going to look at some ways that these, you're getting these mechanics down, which is great. If these rules aren't feeling super comfortable yet, totally understandable. A great thing to put on flashcards and practice with because you want to know them super well so you can just apply them without thinking. Before we do a problem now, I know some people are new to the GRE, so we're going to do a problem called a quantitative comparison problem. And these questions look like this. They have a quantity A and a quantity B, and sometimes some information up top, sometimes not. These are always asking for you to compare the two quantities, to say which one of these two quantities is bigger. And you always have the same four answer choices. So if you pick A, it means quantity A is greater. If you pick B, it means quantity B is greater. If you pick C, it means the two quantities are equal. And if it picks D, it means you can't tell. For today, maybe make a note of these on your paper, but if you ever want to answer a question and you can't remember the letters, you can also just chat in a description like, oh, in this one, they're always equal. Or you could chat C. Good idea to also have these memorized pretty quickly so you don't have to think about them. Now, one little thing to note about this problem, if I pick A, B, or C, I am 100% confident that that relationship is always true. But if I pick answer choice D, doesn't necessarily mean that I've like reasoned it out and decided there's not enough information to be certain. It's just that I know there's at least one case where one is greater and at least one case where something else is true. So it's sort of saying sometimes I'll get one kind of result, sometimes another, depending on what numbers are involved. So A, B, and C, always. D, sometimes one way, sometimes another. All right. Here is a quantitative comparison question involving exponents. I'm going to give you a little bit of time just to try it on your own, and then we'll come back together and talk about it. You are welcome to send me a chat. You can chat me, just me, if you want, if you just chat all panelists, if you get stuck and want a hint. All right. I would like everyone to chat in an answer, even if you feel like this is the most random guess you've ever made. Everyone chat in something. Cool. So the timing for that, I gave you guys 1 minute and 30 seconds, which is on average about the amount of time you'd want to spend on a QC question. Maybe probably not where you're going to start out if you're just doing these for the first time, but this is the goal of where you'd want to get to with timing for this. Cool. So everyone's picking either B or C, and I'm really happy about that because it means everyone's making some smart choices. These are my answers. Which answer choice do I know immediately has to be wrong without having figured out, without like having to do any math, just looking at what my quantities are? Yeah, I can rule out D. Nice. Because these are actual numbers. Like I could, in theory, just calculate what these values are if I had a calculator. Did anyone do that? Did anyone use a calculator? Cool. Yeah, that's good. The GRE calculator is too small to accommodate numbers this big. So you could do this if you have like a nice calculator at home, but you couldn't actually use the GRE calculator for this. Cool. All right, so now I'm faced with comparing these. I know their numbers, they're gonna have a definite comparison, but at first glance, I can't immediately be certain which is bigger because they look kind of different. So I wanna use my exponent rules to get them to match better somehow. Now, it may be tempting, I see 2 and 7, 5 and 10, to say, oh, this is 2 times 7 to the 5 plus 10, and I get 14 to the 15th, so the two quantities are equal. My guess is maybe some people who chose C did that. Why is that? Why can't I do that, though? This is the trap in this problem. This is not what I want to do. Yeah, Munit. Yep. Yeah. Different bases. So I have different bases and different exponents. I can't apply any of my rules here. So even though it looks tempting, I don't want to do this. I'm going to leave quantity A alone, and I'm going to think about doing something to quantity B. And when I think about what I want to do one of two things in a problem like this. I want to match the bases, or I want to match the exponents. For people who did get to a good answer for this, or feel confident in your answer, which of these did you do? Did you match the bases or did you match the exponents? Ah, cool. So Laura, is this what you did? You did 14 to the 5th times 14 to the 10th. Did you match the exponents? Because then I know if I use this rule, it's like doing this adding in reverse. Instead, I'm just going from 14 to the 15th back to 14 to the 5th, 14 to the 10th. And then I see something cool. So now I have 5 and 10 here, and I have 5 and 10 here. And so I see, oh yeah, same exponents, but way bigger bases. So quantity B has to be greater. I could also match the bases. And Munit has put the explanation for that in the chat. I can say like, oh, 14 is 2 times 7. I can rewrite 14 this way. And then I use this rule, AB to the 5th equals A to the 5th, B to the 5th. And I can distribute the 15. How many people did it this way? Splitting up 14 into 2 and 7. Yeah, I know you did, Munit. Anyone else? I'm assuming some people did because I saw a bunch of people getting this right. Yeah, cool. Awesome. I'd say on average, people are more likely to do this, but this works good too. Works well. Wow, works well. It's late. So when I see something like this, I want to match bases or match exponents, and I want to break things down and get them to look like one another so I can compare. Any questions about this? All right. Let's try something different. Here you go. I'll give you a little time to work on it. When you get an answer, don't chat it right away. Just hold on to it, and I'll tell you guys when to chat in your answers. Same deal. If anyone wants a hint, just let me know. All right, now everyone chat your answer. What did you get? Cool. All right, got a mix. So let's think, what are we gonna do? Over here I have 3 to the 11, and over here I have 9 to the x. This is kind of similar in a way to our last problem. Yeah, we're gonna hopefully, Jen, you will be unstuck soon. I'm gonna need to get these two sides of the equation to look more like one another. What would be an easy way to get this 9 to look more like 3? How could I rewrite 9 so it looks more like 3? Yeah, 3 times 3 or 3 squared. Nice. Cool. So I can rewrite it like that, saying like, okay, 9 is equivalent to this. And now I can apply my rules. So I see 3 to the 11th is the same as 3 to the 2 times x, 3 to the 2x. And now I see, cool, I have an 11 here. I have a 2x here. The 3's are the same. So that 11 and that 2x must be equivalent. So I can write a cool little equation, 11 equals 2x, divide both sides by 2, and I get 5.5 equals x. Jen, do you feel less stuck? And also hope I am pronouncing your name correctly, but please correct me if not. And others who got stuck somewhere or had trouble with this, questions. Does it make more sense now? Cool, good. When we see exponents, yeah, it's kind of a weird problem that way. It's sort of a mix of exponents and algebra, but you can't have a fractional exponent like x to the 1/2. What's x to the 1/2 equivalent to? What's another way to say x to the 1/2? X to the 0.5, yeah, or square root. Yep. A fractional exponents are the same as roots. Exponent problems are all about matching. They're about sort of breaking things down or combining things using our rules in order to get sides to balance, to compare. All right, so we're going to kind of continue slowly ratcheting up the difficulty of these problems. Let's try another one. Similar kind of idea where we're looking to match the two sides of an equation, but we have more complicated equations now. And same deal, don't chat in until I tell you. Here you go. All right, everyone go ahead, chat in your answer. Even if you're guessing. Guessing is actually a really important GRE skill. Yeah, this one went well. Yeah, cool. People are getting 9. Nice. Because I see, x cubed, y cubed. I can rewrite that as xy cubed. You know, same exponent means I can combine things to the negative third. So I get xy to the negative 9 on one side. I know, Munit, that is a very GRE-like trick. Xy to the negative z over here. And I'd say like, oh, negative 9, negative z equals 9. I definitely agree. I think the GRE would be very likely, instead of this, to have negative 9 here to get you to miss that exponent. That's very much the GRE's game. Cool. So just using our rules, combining, getting sides to match. Amber, did I answer your question satisfactorily? Yeah. So Amber asked, if I have x, the square root of x, and I want to get rid of the square root sign, I square it, and I get x. If I write the square root like this, it's still the same thing, because then I do x to the 1/2 times 2, which would just give me x. I actually think that this is, like, to me, an even more intuitive way of understanding why we square something to get rid of the square root sign. But it works both ways. You could also think about, squaring a square root is square root of x times square root of x, which would be x to the 1/2 times x to the 1/2. And I'd add those together and get x to the first. Does that make it clearer? Cool. All right. Now we're going to get weirder. Try this one. All right. I realized belatedly that I had the wrong answers up, which is because I have a really bad habit of last minute throwing in problems to my plan. I was like, this is a cool problem, I'll add it. Yeah, so apologize for everyone who had a small panic attack about the nonsense answers. I'm sorry, it was my fault. Here are the actual answers that you should be choosing from. If you need another second to kind of process them, go for it. But when you're ready, chat in the answer. You have it. It should be a regular one. There's this, it should just be, it's not It's not like an exponential addition sign. It should just be a regular addition sign. Cool. Yeah, this one is sneaky. So a lot of love for B. And B would be correct if this was written this way, if it was multiplication signs. And then you guys would totally be right. Like, oh yeah, I add up all those 5s and I get 4 to the 20th. That's our rule. But I don't have multiplication here. I have addition. Do we have any rules for adding or subtracting exponents with the same base? That would be if I would multiply if I had something like this, 4 to the 5th to the 5th to the 5th to the 5th. Then I would multiply and get 4 to the 625. But yeah, all of the rules I gave you guys had to do with multiplication and division. There are no rules for adding or subtracting exponents with the same base. So we're going to have to use some kind of trick here. And it's important that there are 4 of these. If I gave you this, 4 plus 4 plus 4 plus 4, how could you rewrite that with multiplication? Yeah, 4 times 4. So now, if I just made this 4 to the 5th instead, how could you guys rewrite that? Because we know we're going to have rules for multiplication. So how can I rewrite this using multiplication? Yeah, nice to know. It's 4 times 4 to the 5th. Everyone with me? Did I lose anyone? Are those no's as in I am not with you, or no's as in you did not lose me? Yeah. Okay, cool. Imagine, Lauren, that it's x plus x plus x plus x, and you'd write that as 4 times x. Now just substitute in 4 to the 5th for x. And it would be 4 times 4 to the 5th. It's basically 4 times 4 to the 5th is basically just telling me I have 4 to the 5ths. 4 to the 5th times 4 to the 5th would mean I had 4 to the 5th, 4 to the 5th. That would be a ton of 4 to the 5ths. Yep. Yeah. So now at this point, I'd say like, okay, 4 times 4 to the 5th. We're going to get there. We're not, there's another trick along the way. 4 times 4 to the 5th. What's that as an exponent? Nice. 4 to the 6th. Cool. So 4 to the 6th, you guys have done your math correctly if you're getting 4 to the 6th. So right away I know, okay, it's not going to be A, it's not going to be B. But now I'm in a quandary, right? Because I've gotten something that I'm pretty sure is right, but it doesn't match my answer choices. And this is going to happen to you sometimes on the GRE. You're going to do all your calculations really well, and then you're going to look and you're going to be like, oh no, it doesn't match. What do I need to do? If I see like, I got 4 to the 6th, but then there's all these answer choices with 2. What should I do? Yeah, it's similar to what we saw with that 3 to the 11th equals 9 to the x problem. I'm going to take this 4 and I'm going to say, oh, well, 4 is itself a product of 2's. So I could say 4 is 2 squared to the 6th. And I convert 4 to the 6th to the same thing, just with a different base, 2 to the 12th. And I get answer choice D. Marian, I saw you raise your hand. Do you have a question? Does anyone have a question? Did anyone think about this one differently at all? Does anyone have sort of a different way to think about it that's helpful? Cool. So a good rule. There are no rules for adding or subtracting exponents with the same base. So you want to find a way to combine them into multiplication. Or you want to find a way to factor something out of the problem. Yeah, it's kind of a funky trick, but I like it. And there is an official guide. If you flip through the official guide problem, there is an official guide problem that uses this trick. So that's where it came from. I'm happy you've been using Interact though. I work, as you probably, if you've worked on Interact, you know I worked on Interact. So I'm a fan. All right, you guys want to try a harder one? Want to do one super sneaky? Yay, good. Janelle does. So Janelle wins. We're going to do a sneaky one. All right, here you go. Notice we again have addition, so we can't use our rules, but we can use some sneaky tricks. Try it out. I'm going to put a couple of hints on the screen. All right, go ahead and answer. Go ahead and, even if you have to guess, make a guess. Because sometimes you're just going to have to guess and move on the test when things get hard. And it's a good skill. All right, cool. Here again, I could calculate, these are powers of 10, and I could think about it that way and write out like all the zeros and add them together. Did anyone do it that way? No. How did you guys do it? I suggested factoring something out. What did you guys factor out? Ah, cool. Let's try that. Let's try Janelle's way. So we see, okay, 10 to the 5th, 10 to the 6th, 10 to the 7th, 10 to the 4th. What if I pull a 10 to the 4th out of each of these expressions? So I'd say like, okay, I can rewrite this as 10 to the 4th times what? What should go inside my parentheses here? So if I take 10 to the 4th out of 10 to the 5th, what's left? Yeah, 10. Watch out, Elsie, you're right about the 10 squared. But if I'm just taking out 10 to the 4th, then I'll have a 10 left. It would be 1 if I took out 10 to the 5th. Cool. So I have 10 to the 4th times 10 plus 10 squared. And 10 plus 10 squared is small enough I can pretty quickly calculate it. 10 squared is 100, so I get 110. Then I do the same thing over here. I factor out 10 to the 4th. When I take 10 to the 4th out of 10 to the 7th, what's left? What goes inside my parentheses? Yeah, 10 to the 3rd plus 1. Nice. And again, small enough that I can kind of quickly calculate what's inside my parentheses. So I get 1,000 plus 1. And then I have 10 to the 4th times 1,001. So now I see, oh, I have 10 to the 4th on both sides. I can kind of ignore that, right? Because it's balanced. It's the same in both quantities. And I just compare 110 to 1,001. And that's a lot bigger. How many people did it this way? Curiosity. Did anyone have a different method? Oh yeah, Imen, how did you do it? You can give us a quick description. Does anyone have questions about what we just did? So when you see exponents with the same base and addition or subtraction, immediately think, what's the biggest thing I could factor out from everything? You know, pull out the sort of biggest exponent that you see. Like here I see 10 to the 4th is the biggest thing that they all share. So usually the smallest exponent, that's the biggest thing they all share. And then pull that out of all of them. Let's try one that's kind of similar. Let's test out this factoring on another question. So the same technique that we used here where we factored out something, we're going to try here. If you have trouble getting started on this one, chat me and I'll give you a suggestion. Here you go. All right, that is 1 minute and 30 seconds. So everyone chat in an answer. Cool. What can I factor out of both sides? What's the biggest thing that is common to all of the exponents here? Yeah, nice. I can factor out 3 to the 17th. When I take 3 to the 17th out of 3 to the 20th, I get 3 to the 3rd minus 19 minus 17 would leave me with 3 squared. 18 minus 17 would leave me with 3 to the 1st. And 17 minus 17 leaves me with 3 to the 0, which is just 1. Yep, my placeholder. Same thing over here. 19 leaves me with 3 squared plus 3 plus 1 plus 1. And if I ever am not sure I've done that factoring correctly, I can double check just a quick remultiplying. Like 3 to the 17th times 3 squared, 3 to the 19th. 3 to the 17th times 3, 3 to the 18th times 1, 3 to the 17th times 1, 3 to the 17th. I have 3 to the 17th on both sides. And now these are simple. These are just simple numbers that I can do out the math for. And here, 9 minus 27 minus 9 is 18, minus 3 is 15, minus 1 is 14. 9 plus 3 is 12, plus 1 is 13, plus 1 is 14. And I get that they're equal, as many of you did. So cool trick, and it works really well. A problem that initially looks super complicated, just pull something out. And I like a lot of these exponent problems because they kind of work out neatly. They often have these very kind of neat, clever solutions to them. One other thing I note is what I wrote on the screen here is pretty much what I would write if I were solving this on the test. So just something to have in the back of your mind, particularly if you have maybe some trouble with small careless errors, is to write down more. That'll help. All right. I think we have time to do one more before we wrap up. You guys want to do a harder one? Yes. All right. Let's do it. Here you go. Try it out. This combines some of the tricks we've been talking about tonight. All right, that is a minute and a half. Go ahead and chat in your answer. Yeah, cool. This is going well. Did anyone solve this by testing numbers, by just saying m equals 1, so n equals 2, doing out the math? Cool. Brittany did. It's a fine way to do this problem. Particularly if your arithmetic is quick, can be done that way. Nothing wrong with it. There's also an algebraic way to do it. I think it's pretty neat. So first thing, my guess as many of you do, is we plug in m plus 1 for n. Cool. Let's start with quantity b. I hate this plus sign in the exponent. How can I get rid of it? Can I rewrite 2 to the m plus 1 as? So I don't have that plus sign. Yeah, it's just 2 to the first times 2 to the m. It's this rule in reverse. I'm just taking that and going back this way. Cool. Minus 2 to the m. And now I can do my cool factoring trick from the previous problem. Pull out 2 to the m times 2 minus 1. 2 minus 1 is 1, so I get 2 to the m. I do the same thing over here. I have 2 times 2 to the m plus 2 to the m. Factor out the 2 to the m. Over 3, 2 plus 1 is 3. That cancels out, and I get 2 to the m. So the two quantities are equal, which a lot of people got to as a conclusion. One of the things I love about these exponent problems is that, you know, there's maybe 6 or 7 rules to learn, but then there's all of these different strange and cool and funky ways that the GRE can apply these rules to sort of stretch our reasoning and our problem solving and our puzzle solving skills. And they get harder and more complicated and cooler. But unfortunately, we are out of time for today. Before you go, though, one thing I would love for you all to do is in the chat, just share what's one thing you learned tonight that you're going to take out into your studying. What is a takeaway for you from our exponents conversation? Yeah, the factoring out trick. It's a cool one because the first time you see one of those addition problems, it looks really daunting. But then once you learn the trick, like a lot of pattern problems, it's really simple. Nice. Yeah, breaking down exponents, making sure you have the same bases, getting bases to match. Nice. All right. If you guys want more free things, you know, we run these free prep hours a couple times a month. The topics are always changing, quant and verbal. You can also sit in on the first session of our full course for free. You can try Interact, our self-study video product, for free. So go check out our website. Lots of cool free stuff up there. There's recordings of old prep hours like this on our YouTube channel. So best of luck as you prepare. Have a great week, and maybe I'll see you back in one of these